This is a review about the network meta-analysis methods for ranking the accuracy of multiple diagnostic tests. The diagnosis of a clinical condition is usually the first and more crucial step before initiating a treatment. Diagnostic tests are commonly used for confirming or excluding a target condition. In the presence of multiple DTA studies assessing a single index test, a meta-analysis to assess the diagnostic accuracy of the underlying test can be performed. However, when multiple tests exist for a given condition, selection of the best performing test can be challenging. In these cases, a network meta-analysis can be used to simultaneously compare all available index tests and borrowing strength from all the included studies. Ranking the tests according to their sensitivity and specificity is also possible. The aim of this project was to identify and assess all the DTA and MA methods for comparing the accuracy of multiple diagnostic tests. We searched PubMed, Scopus, and Web of Science up until July 2019, and we included 10 methodological studies and 30 empirical DTA NMAs. As shown in the distribution of studies, there is an increase in the DTA NMA applications since 2010, and the first methodological article was published in 2014 by Trekalinous et al. In total, we identified 12 models with different properties, and the majority of these models can be performed in a Bayesian framework. Since the properties of the models differ, results may also differ and influence interpretation and decision making. Of the 10 empirical studies, only 5 provided the code used for their analysis, whereas most of the DTA and MA studies were conducted in UK, as indicated by the affiliation of the corresponding author. Also, the majority of the DTA and MA papers was conducted in the discipline of infectious diseases. For our assessment, we aim to apply the aforementioned methods to all the empirical datasets that we have located in our search and to infer on the strengths and limitations of the methods. As an illustrative example, we compare 3 tests for detecting cervical cancer and CIN2+, with the gold standard, the biopsy. The network that you can see here includes 1 study assessing the cytology test alone, 32 studies comparing cytology and HPV DNA tests, and 4 studies comparing cytology versus HPV DNA versus the mRNA test. To date, we performed 3 different approaches: the bivariate meta-regression model, the ANOVA model, and the beta-binomial model. The bivariate meta-regression model uses as a covariate the test type to explore sensitivity and specificity between tests. Although this is the most popular method, it does not account for the within-study correlation between the tests due to serving the same individuals across tests, and it assumes independence between tests to build the between-study variance-covariance matrix. The ANOVA DTA NMA and the beta binomial models include a shared random effects parameter to account for correlation between tests. The ANOVA model is a hierarchical model using the logit transformation of sensitivity and specificity, whereas the beta binomial model defines sensitivity and specificity through a beta binomial in the interval of 0 and 1. The latter uses a copula to describe the dependence between sensitivity and specificity and provides us with the mean and over-dispersion of sensitivity and specificity. Our results show that the models are overall in agreement. Cytology is associated with the lowest sensitivity but the highest specificity among the tests. The HPV DNA test improves sensitivity with comparable specificity, and the mRNA is associated with both high sensitivity and specificity, but with higher uncertainty around these estimates, which might be probably due to the small number of studies comparing the test. In total, among the DTA and MA models accounting properly for the between-test correlation, the estimates obtained by the ANOVA model are more precise with shorter confidence intervals. Using the diagnostic odds ratio as a ranking approach, we also see that the mRNA is suggested as the most accurate test under all the models. Next, we will apply all models to our database of the diagnostic test accuracy network meta-analysis data, and we will empirically assess the properties of the models. Thank you for your attention, and please feel free to email us your questions.